Hello scholars, welcome back to the Kemet Maasai Academy. Today we're going to be looking at the number of elements in a set. Before we go any further, let me ask you please to subscribe. If you have not already done so, just click that subscribe button. And also remember to tell your friends, your siblings, everyone about the Kemet Maasai Academy channel so they can benefit from all of these videos just as you are benefiting. Remember also, drop me a comment, let me know what you think about the videos, and let me know if you want me to do a particular topic, right? So just leave a comment or just to say thank you, I would appreciate it. So let's go. We're looking at the elements in a set. So when we're talking about sets, of course, we're talking about a collection of items that share some common traits. And if you have been watching all the other videos that we have on sets at the grade 4, grade 5 level, you will remember that we use the Venn diagram to represent the universal set. So the universal set is a collection of all the elements being considered. In the universal set, we will have different minor sets, special sets, where we categorize the elements. If the sets overlap or they intersect, so that means those sets have something in common with the other sets that overlap. So what we're focusing on today is actually counting the elements in the sets. Not just listing them, but counting them. So where you see this N, it means the number of elements in that set. And of course, we usually use capital letters to represent the sets. So the number in set A, we would count how many elements are in set A. And that is known as the cardinality of the set. So the number of elements in a given set is known as the cardinality of that set. And cardinality comes from the word cardinal. You will remember a cardinal number is a number that tells you how many things. 1 thing, 3 things, 100 things. That's the cardinal number, right? So that's also the counting or natural number. Remember, we count things starting with 1, and we continue by adding 1 each time as we count. So after you count up how many things, that final tally, that final number that you get after you've counted all the things, that is the cardinality. So what we're going to be doing today is just counting the elements in our sets and finding out the cardinality of that set. So let's look at our Venn diagram. We have the universal set is equal to 16. So that tells us, remember, the universal set represents all the elements that are being considered. So the number in all the sets should add up to the universal set. So here we have, within the universal set, we have set A, set B, set C, and we have some elements out here, some rogue elements, some introverts who don't want to be associated with the other sets. They like to be by themselves over here in the corner, but they are still a part of the universal set. They still have to be counted in terms of the universal set. So everybody in here should add up to 16. The cardinality of the universal set is 16. Let's double check. Let's count to make sure that that is correct. So these two guys out here, or girls, who want to be by themselves, you know, sometimes you just want to be by yourself. It doesn't mean that you're antisocial. You just want to hang out by yourself or with others who, you know, are quiet and just want some quiet time. So we have two students over here who are like that. So that's 1, 2. And then we're going to count also the others who are more involved in the social group. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. That's the universal set. So everybody together, 16. That's the cardinality of the universal set. So now, let's go down and count the elements that are in these descriptions. Now remember, these are written using set notation. If you're not familiar with set notation, just check the playlist, the grade 4 playlist or the grade 5 playlist, and you will find the video on set notation where I break down for you what the different symbols mean. But I will tell you here also as we go along. So this means the number of elements in set A. So we're just focusing on set A. How many elements are in set A? So set A is this circle here. Everybody who is in this circle, including where it overlaps with set B and set C. So these guys here, they are in set A also in set A, right? They overlap with B or C, but still in set A. So we have to count them if we want the number in A. So 1, 2, 3, 4, 5, 6. So the cardinality of set A is 6. The number of elements in A is 6. How about the number of elements in set B? So this is set B. So that's 1, 2, 3, 4, 5, 6, 7. How about the number of elements in set C? Okay, so set C, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 elements in set C. The number of elements in A union B. So those are the students or items that are in A or B. So we have to count them both. A, those who are in A, those who are in B, the union of them. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Those who are in both A and B, we don't need to count them twice. We just count them once. So that's 11 elements in A union B. A intersect B. Where does A and B overlap? So what are the elements in both A and B? So that's these right here. See, where set A overlaps with set B, that's 2 elements. The number in A union C. So A union C. So this is A and this is C. So their union together, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, also 11. A intersect C. The number of elements in A intersect C. So this is where A and C overlap. This is A overlapping C. That's 1, 2, 3, 4. How about the number of elements in B union C? So that's B, that's C. We want their union, combining them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And B intersects C, so that's where B overlaps or intersects with C. 1, 2, 3, 4. Now we want the number of elements where A intersects B intersects C. So where the 3 sets overlap. All 3 circles overlap. So that's in here. Because we have A and B and C. So right in the middle here, that's 2 elements. The number of elements in A union B union C. So we're going to combine A, B, and C. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Now, for those who are familiar with set notation, and as I said, if you are not, just check our video explaining the different symbols used in sets. This symbol here means the complement of, or what's not in. So the number of elements that are not in the union of A, B, or C. Remember, we already said the union of A, B, and C is 14. That's all of these. So who did we say are not in A or B or C? Remember those 2 elements out here who like to just stay by themselves? They are not in the union. They are in the complement. Complement means not a member of. So that's 2 elements that are in the complement of the union. The number of elements in A complement. What's not in A? Remember, complement, this little stroke to the right. The little stroke at the right hand side means not in, the complement. So what's not in A? This is A. So what's not in A? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that makes sense since we know that there are 16 elements in the universal set. And we knew that there are 6 elements in A. So if there are 16 in all and 6 in A, so what's not in A should be 10. That makes sense, doesn't it? What's not in A should be what's left back after you take out the 6 out of the 16. And we counted it to make sure. Now, the number in A complement intersects B. This means what is in B only. B only. Not where B intersects with A or C. Just B alone. So that's these guys here. They are only in B. They are not in the part of B that intersects with C or A. So the number of elements in B only would be 1, 2, 3. Alright, so let's look now at finding the number of elements in these sets that are described here. So we have the sets defined, the number of elements in A, such as A is equal to whole numbers between 6 and 12 inclusive. So where it says inclusive, that means you're going to include the 6 and the 12. You're going to include the end points. Right? So now, we first need to list those elements. So, whole numbers between 6 and 12, but we're including 6 and 12. If it had just said whole numbers between 6 and 12, then we would not include the 6 and 12, just the ones in between. Or if it had said whole numbers between 6 and 12 exclusive, so they're telling us do not include 6 and 12, just the ones in between. But because it says inclusive, we are going to include the 6 and the 12. So whole numbers 6, 7, 8, 9, 10, 11, 12. Remember, normally when you are told to list elements between two endpoints, you do not usually count the endpoints, just the ones between. But you have to look to see if they want you to include them. They will tell you inclusive. Alright, so let's count. So the number in A then would be 1, 2, 3, 4, 5, 6, 7 elements. The number in P such that P is the perfect square numbers less than 60. Remember, a perfect square number is a number that you get when you multiply any number by itself. So the first square number is 1 because 1 times 1 gives 1. So 1 is a perfect square number. 2 times 2 gives 4. 4 is another perfect square number. The perfect square number is less than 60. So 1 is the first square number, then 2 2s 4, 3 3s 9, 4 4 is 16, 5 5s 25, 6 6 is 36, 7 7 is 49, 8 8s would be 64, but they want less than 60. So we have to stop it here. So the number of elements in P would be 1, 2, 3, 4, 5, 6, 7 again. So there are 7 perfect square numbers less than 60. The number of elements in R, such that R is, whenever we're given a set defined in this way, we read from the middle. So we read from the middle that way and from the middle this way. Now this is a less than sign, but because we're reading from the X, we're saying X is greater than 8. Remember, normally we'd say 8 is less than X, but we're reading from the middle. So we want the numbers where X is greater than 8 and less than 14. So let's list those elements in set R that are greater than 8 and less than 14. So don't be confused. I'm calling this greater than. You know it's the less than sign. I'm calling it greater than because I'm reading from the middle and the open mouth is turned to the X. If I was reading the normal way from left to right, I would say 8 is less than X. So don't be confused. So we're saying X is greater than 8 and X is less than 14. So what's the first number greater than 8? So that would be 9, 10, 11, 12, 13. We're not including the 14 because it says less than 14. So we stop there and we're going to count the cardinality, the cardinal number. 1, 2, 3, 4, 5. There are 5 numbers that are greater than 8 and less than 14. Finally, the number of elements in B such that set B is equal to prime numbers that are even. If you don't know what prime numbers are, you know what I'm going to say. Check the playlist, find the videos that were done on prime numbers. We have a couple of videos specifically explaining what prime numbers are. Briefly though, a prime number is a number that has only 2 factors. Only itself and 1 can go into it. The first prime number is 2, and 2 happens to be the only prime number that is even. Because all the other numbers that are even, they automatically have another factor than themselves and 1. They have 2 that can go into them. That's what makes them even. So 2 is the only prime number that's an even number. So set B only has 2 in it. So the number of elements in B then will be 1. Just the number 2, just one number. There's just one even number that is prime. And that wraps it up for the number of elements in a set. The cardinality of a set. All we need to do is to count the elements and write it. If you have been helped by this video, drop a line in the comments to say thank you. Also, please share the video with your friends, your neighbors, your siblings, your church members, everybody, so they can benefit as well. And let me know if you want me to do a video on a particular topic. Check the playlist first because we have dozens and dozens and dozens of videos. But if you can't find the one you want, just let me know in the comments and I'll certainly do it for you. If you have not subscribed as yet, please do so. When you subscribe, you allow the video to rank higher, and that will enable other students to find the videos more easily. So just do me a favor, click subscribe, click share, and drop a comment. Let me know what you think. I'll see you in the next video.